a transpose of a matrix. Transpose of a matrix. Transpose of the matrix, we always represent the matrix with A is equal to Aij, the number of rows, that is m cross n. If it is a transpose of the matrix, that will be either we write in this way or we write AT is equal to, the row will become the column. So they will interchange, the row will become column. So it will be A, that is Ji into n cross m. So the number of rows will become the number of columns. It is represented by the A dash or the AT. Let's take the 2 cross 2 matrix. A is equal to 1, 2, 3, 4. Now A transpose will be A transpose. Familiar with this? So I am writing with this, both are correct. Now the row will become the column. So this is the row, this row will become column. So it will be 1, 2. Again the second row will become the second column. So 3, 4. This is the transpose of the matrix. So we have the certain property. What are the properties of the transpose of the matrix? Means the first properties of transpose of the matrix. Transpose of the matrix. The matrix. First property, if we take the transpose of a matrix, again transpose, it gives the original matrix, that is A matrix. This is the first property. Second, if we multiply with A, with the matrix means scalar multiplication, then take the inverse, it will be equal to constant, that constant into A transpose. K be any constant value. So where K is any constant. Third property, that is addition, A plus B. Either add the 2 matrices and take the transpose, it will equal to take the transpose and add it later on. So that is A plus B transpose equal to A transpose plus B transpose. These two will be equal. Now for the multiplication. Multiplication is a little bit different. So we cannot write A transpose into B transpose. It will give B transpose into A transpose. AB whole transpose will be equal to B transpose into A transpose. So in the multiplication, it have to be a little bit careful. See, in the addition, it's same. Means take the transpose or take the addition, it will give the same result. But here in the multiplication, AB whole transpose is equal to B transpose into A transpose. Now here we have the two theorem. The proof is not required, only the theorem. What does the theorem stated? Oh no, before the theorem we need the symmetric and the square symmetric matrix. So first, symmetric and square symmetric. Symmetric and square symmetric. What is a symmetric matrix? Symmetric matrix. Here also we are going to take the transpose. When transpose of A, that is A transpose equal to A, that is a symmetric of the matrix. Square symmetric, when A transpose equal to minus A, is a square symmetric matrix. And you have to remember that all the diagonal of the square symmetric is 0. All the diagonal is 0. All the diagonal is 0. Means here the matrix can be any matrix, but in the square symmetrics the diagonal will be always 0. Symmetrics, when you take the transpose of the matrix, it will give the original matrix, that is a symmetric. When you take this transpose of the matrix and it comes in the negative of the original matrix, that is the square-symmetric matrix. So let's the example of this, that is A is equal to symmetrics. So this will be A is equal to, let's take the one example of the symmetric matrix. So A is equal to root 3, 2, 3, 2, that is minus 1, 3, minus 1, symmetric. So take the transpose of this matrix, that is A transpose. A transpose, the row will become column. So A transpose equal to, the row will become column, that is root 3, 2, 3, 2, minus 1, minus 1. So 3, minus 1, 1. See, is it say the same? So this equal to give again A. So this is a symmetric matrix. Now the example of the square symmetric. This is complete. Now it's a symmetric. Let's just symmetric. A is equal to, let's say 0. The diagonal have to be 0. So 1, 2. Here will be 1, minus 1, minus 2, 0, 3, 3. This will be minus 3, 0. So take the A transpose. A transpose will be, the row will become column. The row will become column. The row will become column. So it was 0, 1, 2. So here will be minus 1, 0, 3, minus 2, minus 3, 0. Thus these two equal are same? Not yet. If you take the minus common, only it will be the same. So take the minus common. See now, take the minus common. So it will be, because we know it minus into minus is the plus. So it equal to 0. This will become 1, 2. It will give minus 1, because a minus into minus it give plus. Minus 1, 0, 3. Or that is minus 2, minus 3, 0. So now only this became the A. So that is minus A. When A transpose is equal to minus A. So this is a square symmetric. When A transpose is equal to A, that is a symmetric matrix. And you have to remember, in a square symmetric matrix, the diagonal is 0. So we have the two theorem. There is the first theorem for any square matrix. So okay, I'll explain it in a book. The first theorem states that for any square matrix, means what is a square matrix? A square matrix when the number of rows and the number of column are equal, that is the square matrix. For any square matrix with the real entries, means in the element are all the real number, then A we have the A, and if we take the transpose, then add these two matrix, it will give the symmetric. The first matrix, the A matrix. If there is the A matrix and take the transpose of A matrix, if we add A with that A transpose, it will give the symmetric matrix. And if we subtract from the A minus A transpose, it is a square symmetric matrix. So there will be a matrix A, take the transpose of this and add with A, it will give the symmetric. Subtract from A, it will give the square symmetrics. That is the first theorem. Now second theorem. In the second theorem, what does it say? Here also it is a 2 cross 2, not the 2, square matrix. It can be 2 cross 2, it can be 3 cross 3. Here we are going to deal on after the 3 cross 3 matrix. So any square matrix expressed as the sum of a symmetric and a square symmetric matrix. So what is it? that is, if we have the A matrix, that A matrix can be written as the sum of symmetric matrix and the sum of square-symmetric matrix. That is, A equal to, you have to remember this, A is equal to, see, we know this A plus how much? A plus A in A transpose. This is a symmetric matrix from the first theorem. And A minus A transpose, this is also square-symmetric matrix. So divided this by 2 and divided this by 2, this total, if you solve this, and you will give the main matrix, the original matrix. That's the statement, mean to say that when there is a matrix, that A matrix can be written as the sum of the symmetric matrix and the sum of the square-symmetric matrix. Square-symmetric matrix. So this is the symmetric matrix, this is a square-symmetric matrix divided by 2, a sum means addition, it will give the original matrix. So now it's exercise. The first exercise, question number 1, 3.3. question number 1, write the transpose of each of the matrix. Means you have to change the number of rows, the rows will change to the column. I think it's sufficient. Exercise 3.3. question number 1, Roman number 1, it's given 5 1 by 2 minus 1. So this will be the A. So that is A is equal to this one, and we need a A transpose. The row will become column. Sorry, here it's, yes, the row will become the column. So this is the row, row, row. So this will become the column. So 5 1 by 2 and minus 1. Question number 2, A is equal to 1 minus 1 2 3. So it will be A transpose. So A transpose will be, the row will become column. So the row will become column 1 minus 1 2 3. Roman number 3, that is 3 cross 3 matrix. So minus 1 5 6 root 3 5 6 2 3 minus 1. This is the A matrix. A is equal to, now we need a transpose. Okay, let's complete it here. So A transpose, the row will become column. So minus 1 5 6 root 3, the second row will become the column 5, that is 6 2 3 minus 1. So this is the A transpose. Now question number, Roman number 2, not Roman number 2, question number 2. Question number 2, two square matrix is given. Why it is a square matrix? It is a border 3 cross 3 matrix, therefore it is a square matrix. This is question number 2. If A matrix is given, B matrix is given, border say 3 cross 3 matrix. So whenever it's for the addition or the subtraction, the number of rows and the number of columns of the two matrices have to be equal, then only the operation of addition and subtraction is applicable. But in the multiplication, if the number of rows and the number of column of the two matrices are equal, the multiplication is applicable. So we can perform the multiplication. Here it's the subtraction and the addition. So this is the transpose, sorry, this is the A and this is the B matrix. We have to verify that A plus B whole transpose is equal to A transpose and B transpose. A transpose plus B transpose. A Roman number 2, A minus B whole transpose is equal to A transpose minus B transpose. So first, this is a matrix. We have to find the transpose of the both matrix. Here first add it and find the transpose. So first, let's write the given matrix. question number 2. Question number 2, given matrix A is equal to -1 2 3 5 7 9 -2 1 1. This is the A matrix and this is the B matrix. -4 1 -5 1 2 0 1 3 1. Question number 1, what is the target? A plus B whole transpose is equal to A transpose plus B transpose, or left hand side equal to right hand side. Let's find this one first. A plus B. A plus B. What is A plus B? -1 2 3 5 7 9 -2 1 1. This will be added with B matrix. So for 1 -5 1 2 0 1 2 0 1 3 1. This is equal to, add this number, -1, directly we can do for it, -4 -1, that is -5, because we already know it how to add. So 2 plus 1, that is 3, or 3 plus into minus is minus, 3 minus 5, it will give -2. Now 5 plus 1 6 7 plus 2 7 8 9, or 9 plus 0 9, -2 plus 1 -1, 1 plus 3 4, 1 plus 1 2. Now this one we got. Now let's go for this A transpose plus B transpose, A transpose plus B transpose, A transpose. Make the row column. So -1 2 3, so it will give -1 2 3. Second row 5 7 9, 5 7 9, -2 1 1, -2 1 1. This is A transpose plus now B transpose. B transpose, row will become column. So row will become column. So -4 1 -5 1 2 0 2 0 1 3 1, that is 1 3 1 3 1. Now add this, -1 plus into minus, so -4, that is -5. 5 plus 1, did we make a mistake? 3. So 2, now it's here. 5 plus 1, 5 plus 1 6, -2 plus 1, that is -1. 2 plus 1 3, 7 plus 2 8 9, 1 plus 3, that is 3, 1 plus 3 4, of 3 minus 5, that is -2, 9 plus 0 9, 1 plus 1 2. We have to find the A plus B whole transpose. So that is, let's A plus B whole transpose is equal to, the row will become the column. So it will give, this is nothing, the row will become column. So that is, the row will become column, -5 3 -2 6 9 9 -1 4 2. Let's see, -5 6 -1 3 9 4 minus 2 9 2. So now these two are equal, therefore A plus B whole transpose is equal to A transpose plus B transpose. Now Roman number 2. The matrix are same. Here is the subtraction. This is Roman number 2. Here the matrix A minus 1 2 3 5 7 9 minus 2 1 1. Matrix A, and matrix B, that is minus 4 1 minus 5 1 2 0 1 3 1. A minus B. We have to show A minus B whole transpose is equal to A transpose minus B transpose. So let's find A minus B. A minus B. Matrix A, that is minus 1 2 3 5 7 9 minus 2 1 1. This is the matrix A minus matrix B, that is minus 4 1 minus 5 1 2 0 1 3 1. Do the subtraction. So minus 1 and minus became plus, so minus 1 plus 4, that is 3. 2 minus 1 1. 3 minus plus minus and minus became plus, 5 6 7 8. 5 minus 1 4. 7 minus 2 5. 9 minus 0 9. Minus 2 minus 1 minus 3. 1 minus 3 minus 2. 1 minus 1 0. Now we need a transpose of this, that is A minus B whole transpose. The row will become column. 3 1 8 4 5 9 minus 3 minus 2 0. Now subtraction A transpose minus B transpose. A transpose, the row will become the column. So this is the A, the row will become column. So it will be minus 1 2 3. Second row 5 7 9. Third row will become the third column, minus 2 1 1. This is A minus, we need a B. This B will be the matrix B will be the transpose of matrix B. The row will become column. So minus 4 1 minus 5. So minus 4 1 minus 5 1 2 0 1 3 1. Now the subtraction of this matrix we can do directly, because we already became the expert while doing the subtraction and addition. We can go for direct. So minus 1, here minus and minus became plus, so minus 1 plus 4, that will give 3. 5 minus 1 5 minus 1 4. Minus 2 minus 1 minus 3. 2 minus 1, that is 1. 7 minus 2, that is 5. 1 minus 3 minus 2. 3 minus and minus became plus, so 5 plus 3 5 6 7 8. 9 minus 0 9. 1 minus 1 0. Now check these two matrix. Thus the two matrix, these two matrix are equal. Now this matrix and this matrix are totally the same. Therefore A minus B whole transpose is equal to A transpose minus B transpose.